The second step of the HPA 10-step motorsport harness construction process is determining how the harness will physically route through the vehicle and the engine bay. With the first step of the process completed, we have a design for how all of the components will be electrically connected, but we need to determine how the harness will physically connect to the parts of the EFI system. Before we can finalise this, it's ideal if all of our components are physically mounted so that their location is finalised and we can then decide on the best harness routing. This is a bit of a case of the chicken and the egg though, as the mounting location is often driven by how and where we can feasibly run the harness, and what harness routing will provide the most reliable end result. I'm talking here about taking into consideration heat sources like exhaust systems, movement and vibration that the harness will need to handle, and ensuring that the harness is protected from anything that could contact it and abrade through it. When considering the component mounting from an electronic standpoint, we have the ECU to consider first and foremost, but while deciding where to mount this, we also need to keep in mind where we want to bring the bulkhead connector through the firewall. There's no point mounting the ECU in a location where we'll have a needlessly long run of wiring between it and the bulkhead connector. Conversely, we want the harness length to be long enough for us to be able to easily work with and terminate the harness. Very short sections of harness can become tricky when it comes time to terminating the connectors and booting them. Another consideration before finalising the bulkhead connector location is the way the harness will run from the firewall to the engine. This is a region where we can expect some relative movement as the engine rocks side to side in the engine mounts. While this is unavoidable unless your engine is solid mounted, we do want to make sure we allow for this by providing a slack section of harness that can move without focusing this movement into the Autosport connector. With this in mind, we decided on a bulkhead connector located on the driver's side of the firewall at approximately the same height as the cam cover for bank 2. This gives us plenty of clearance to the exhaust header below and any other heat sources. A small complexity with this location is that the engine is actually fitted a long way forward in the engine bay. There's around 120mm or about 5 inches between the firewall and the back of the cylinder head. This is helpful in a way as relative movement won't be focused directly into the bulkhead connector. However, we also need to support the harness here. We determined we could achieve both aims by directing the harness down towards the bell housing and then positively locating it to the back of the engine. By leaving a small loop in this section of harness, we can safely absorb any movement. With the bulkhead connector location finalised, we can mount the ECU. We want the ECU hidden out of sight, and there's not a lot of space in the FJ40 that's suitable. In the end, we decided to mount this above the steering column, which allows for a modest harness length between the ECU and the firewall. We're going to have additional branches required on this harness for the likes of our PDM power supply, our Ethernet communications, CAN bus, our dash, and some pass-through wiring for functions we'll deal with in more detail as we get further into this example. While not specifically the subject of our worked example, it's worth mentioning the location we selected for the two Motec PDM32s. Mounting considerations for these include the ease of connection to 8 individual Autosport connectors first and foremost. It's very easy to end up mounting these units in such a way that it makes our lives really tricky when it comes to routing the individual harnesses to the units, as well as installing and removing the Autosport connectors. The other consideration is that we want to ensure they're located in an area where they'll receive sufficient airflow. These units can generate substantial heat in operation, so mounting them in tight confines isn't advisable. Traditionally, we'd normally split the power load between the two PDMs to the front and the rear of the vehicle and mount them accordingly. However, there really was no suitable location for a unit at the rear of the truck, so we chose to mount them side by side in the center of the firewall. When we're building a custom harness like this, we also need to consider how the harness can be positively located to prevent unwanted movement, as well as to protect the harness and keep it routed neatly as intended. There's a variety of options we can use, including P-clips, cable ties, or dedicated alloy tabs that can be epoxied in locations where the wiring needs to be secured, and then the wiring can be secured to these tabs with a zip tie. You'll see these in action as we move through this example. Once we're comfortable with the location of all of the components and we have a basic plan in mind as to how the harness should run, we can use nylon rope to replicate the harness as well as the branch points. The advantages of using nylon rope are multiple, but primarily it's cheap and easy to source. It's also available in different diameters, so we can accurately replicate the different sections of the harness. Nylon rope also tends to bend in a similar way to our completed harness, which means that the finished harness should replicate our mock-up when it's fitted to the engine. Anytime we need to add a branch to the main harness, we can do this by adding a new section of rope and then taping it in place using insulation tape, zip ties, or a combination of both. On a complex harness like this, with a lot of sensors and actuators to consider, I like to add a note to the end of each section so I can reference the termination when it comes to creating the harness documentation. This saves time and avoids any potential confusion. It can also be completed easily using just masking tape and a Sharpie marker. Once we have our rope harness designs complete, we can add this to our documentation. There's a variety of ways we can achieve this, but in our case, I'm simply using graph paper, a ruler, and a pencil to document the harness, adding details on the length of each branch as well as the terminations. Once completed, I've simply taken a photo of this design on my phone and then added it as an image to my Google Sheet, so I've always got this as a reference and it can't be lost or misplaced. With a little time and effort spent here, we should essentially have a roadmap for our interior and our engine bay harnesses, which we can then use to build our documentation from in the next step.
That was just one of 48 lessons taken from our professional motorsport wiring course. This course is perfect to help you learn the skills of designing and constructing professional or mil-spec style wiring harnesses. You'll learn the fundamentals of automotive wiring as well as the tools and materials required. You'll learn about Autosport connectors, how to select the right one for your application, and how to correctly terminate them. You'll also learn all of the specific practical skills that go hand in hand with constructing these harnesses. From here, you'll learn a simple 10-step process that you can apply to your own wiring jobs, regardless whether you're building a simple sub-harness or perhaps wiring your engine and chassis from scratch. Each step of this process is quick and easy to complete, and in no time you'll have a complete harness that's been properly designed, documented, constructed and tested, so you'll have the confidence that it'll work right the first time. We also include a library of worked examples within the course where you can see the 10-step process being applied in real time on a real wiring job. This course will be perfect regardless whether you're working on a car, a motorbike or an off-road vehicle. The skills are 100% applicable. If you want to find out more, click the link.